Hi, let's briefly talk about one of our simple machines. It's a very simple one, an incline plane. Imagine that you have an object that has some weight, and it's on the ground floor, it's outside, and you would like it to be in a building which is slightly elevated. Most of us can appreciate having some steps to walk up to get into our house, maybe, or the school or somewhere where you don't get to just walk in on ground level. Okay, and in order to get it to this level, to get it into the building, you would have to just pick it up and bear the full weight of this object. So however much this, let's say this is 100 pounds, you've got to just lift 100 pounds to get it up over this. Well, what if you are not able to lift 100 pounds? Is there another option? And there is. What if we have an incline plane, a ramp, per se, like a wheelchair ramp, that instead of having to lift this up, we could push it up. That way we don't have to put the full force in. An incline plane is a simple machine that will give us a mechanical advantage. Let's think about this object that weighs some weight, like 100 pounds. That is a resistance force. And we hope that we can come behind it and push. In the end, we're going to push kind of parallel to this ramp, to this incline plane. We're going to push with some effort. And ignoring friction, okay, we should be able to push with less force than the resistance is itself, so that we can slide it along here. Again, ignoring friction. So the actual mechanical advantage is going to be Fr over Fe. Now we do know that friction comes into play, and it won't be perfect, but we expect to get some mechanical advantage here. Imagine a wheelchair that can roll, right? There's going to be some friction, but not nearly as much. Hopefully you realize that you may be able to push somebody in a wheelchair up a ramp, but that doesn't mean that you could have just lifted them up, their full weight. Let's say it's a 200-pound person, plus the weight of the wheelchair could be another 20 pounds. You might not be able to just bend over and pick up 220 pounds, but you may be able to push them up a ramp. Now with our simple machines, not only do we have an actual mechanical advantage, but we have, that one would take into account friction, we would have an ideal mechanical advantage. So, or an IMA. This one will ignore friction and just in theory, based on this ramp, this incline plane, tell us what kind of a mechanical advantage we would hope to get. Okay, now to figure that out, we need to understand distances. IMA, the formula, is the effort distance divided by the resistance distance. So what that means is, what is the distance traveled by the resistance? In this case, the whole goal was to get the object up to level 1. So the distance traveled, or desire of travel, what we're trying to accomplish is simply to move it vertically. So this distance from here to here, this is going to be dr right here. Okay, it's just that vertical change. That's what we're trying to accomplish. However, we don't get to go in a straight line. If we did, we'd have to just pick up the full weight, right? So look at the path that we take, the effort path to get there. We start here and we push up the ramp right here. So this path, the length of the ramp is our effort distance. We're going to sit here, we're going to push until we get to the top. So that ratio, the ratio of the distances, the effort distance as I push, the path in which I take as I push is my effort distance, okay, divided by the resistance path, which is our goal, was to simply raise the object to this level 1 height. And there you go, is the ideal mechanical advantage. Now we expect the IMA to be larger than the AMA. We don't think we'll get as big of a mechanical advantage as we could get. We usually get a little less, again, because of friction. And if we found those, both of those, we could go back and figure out kind of the efficiency of this simple machine. Let's just give some examples. Let's say we had an incline plane as an example, got an IMA of, how about 10, and had an AMA of 9. We'll just keep it really simple. So we would ask, what is the efficiency as a percent? Well, kind of like when you figure out your grade on a quiz or test in class, you figure out, you may say, hey, it's out of 10 points. I got 9 out of 10, and I got, in essence, a 90%, right? Well, the formula, if we just write it out here, is to take the best possible you could get, which is the ideal, that's in theory the best you could get, okay, and divide the actual by that. So what did I actually get divided by what I could have gotten, and that'll give you a decimal like 0.9, and so then we're going to multiply by 100. So AMA over IMA times 100 will take that 0.9 and turn it into 90%. So there you go. Now we understand an incline plane. We understand how to calculate the actual mechanical advantage of it, simply dividing the forces like our other simple machines, and how to calculate the ideal mechanical advantage. What is that elevation gain we're getting? That's our resistance, distance, and what is the path that we have to take? What is the distance of that path to go up the ramp? Okay, and that gives you the ideal.